Messy data can throw your model off, but scaling fixes that. In this video, we'll code feature scaling methods like min-max scaling and standardization, step by step. Welcome to day 27 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. By the end, you'll know exactly how to implement feature scaling in Python and when to use each method. Let's jump in. First things first, importing the essential libraries. Pandas for data handling, NumPy for numerical operations, Matplotlib and Seaborn to make our visuals pop. Loading the dataset into Pandas. A quick head lets us peek at the first few rows, and shape tells us the dataset's dimensions, rows and columns. Dropping the unnecessary ID column. Cleaner data, better focus. The errors equals ignore ensures no crash if the column isn't there. Handling missing data like a pro. Numerical columns get the median, while categorical ones use the most frequent value, keeping the dataset balanced and reliable. Selecting numerical columns and filling in missing values with the median. This keeps the data consistent without being affected by extreme outliers. Picking out categorical columns and replacing missing values with the most common category. This helps maintain patterns without introducing randomness into the data. Converting categorical columns into numerical form using one-hot encoding. Time to visualize correlations. A heat map reveals relationships between features. Darker shades mean stronger connections. Helps in spotting dependencies before scaling. Splitting features and target. X holds all predictors, while Y isolates the sale price. Readying the data for scaling and model training. Plotting the target variable's distribution. The histogram with KDE shows if sale price is skewed or not. Visualizing the relationship between GR live area and sale price. Exploring feature relationships. This pair plot shows how key variables interact with sale price, revealing trends, correlations, and potential outliers before scaling. Splitting data into training and testing sets. 80% for training, 20% for testing. Ensuring the model learns patterns before evaluating performance on unseen data. Defining 3 powerful scalars. StandardScaler standardizes data with mean 0 and variance 1. MinMaxScaler scales between 0 and 1. And RobustScaler tackles outliers by using the median and interquartile range. Each serves a unique purpose, ensuring models perform optimally regardless of data distribution. Let's apply them next. Testing different scaling methods in action. We loop through StandardScaler, MinMaxScaler, and RobustScaler, applying each to our training and test sets. Scaling ensures that features have consistent ranges, helping models perform better. Once scaled, we train a linear regression model on X-train scaled and predict Y-test. Then, we evaluate performance using 3 key metrics. Mean absolute error, MAE, measures how far predictions are from actual values in absolute terms. Lower is better. Mean squared error, MSE, penalizes larger errors more than MAE, giving a stronger signal for significant mistakes. R-squared score tells us how well the model explains variation in sale price. Closer to 1 means better predictive power. Finally, we print the results for each scaler to compare which scaling technique improves model performance the most. The right scaler can significantly impact accuracy, so choosing the best one matters. And that's how feature scaling transforms your data for better model performance. We tested different scalars, trained a model, and saw how scaling impacts accuracy. Choosing the right scaler can make a huge difference. But why stop here? In the next video, we're diving into ensemble learning, where multiple models work together to deliver even stronger predictions. Curious how? Click on the screen to continue, and I'll see you there.